acronym as far as required inspections, but in rehearsing this thing, I found out it wasn't quite long enough just talking about that acronym. So I've thrown in a few extra ones here to make sure that we can spend at least an hour doing this thing. And while I share my screen here, so everybody can see what's happening here. And pull this one up so I can continue to look at my camera. So we'll be going over in this hour of some aviation acronyms and the sources, the regulations that that have gained these where all these acronyms come from. Why do we memorize these acronyms in the first place? So we'll be going over the AVIATE acronym eventually, but we'll start out with the aircraft documents that are required, which most people use the word AERO to remember. And then we'll move on to the AVIATE acronym and talk about where all the regulations about all the different types of required maintenance that are listed in the AVIATE acronym. Then we'll do 91.103, the pre-flight actions, which most people use as the acronym NW CRAFT with a K. And finally, 91.205, the required equipment for flying for VFR day, VFR night, and IFR. So that's AF tomato flames is one way to do it. The night stuff is flaps, and the IFR stuff is grab card. So let's start with the airworthiness certificate, the A in AERO. 91.203 says that you have to have an airworthiness certificate in the airplane. And it must be the current airworthiness certificate. This is basically the certificate that comes with the airplane when you buy it, when it is manufactured when it is manufactured. The FAA does a check on the airplane and issues the airworthiness certificate as it comes off the line. So most of the time, the airworthiness certificate you probably have in your airplane was the one that came up, that was given to the airplane back in the days when it was the day it was manufactured. So there's no expiration date on this airworthiness certificate. That's why we're going to go over the AVIATE acronym, because those are all the maintenance things that you have to do in order to be able to maintain the airplane in an airworthy condition. The next one is the letter R in AERO. There's registration. Depending on where you're listening to this seminar from, if you're from the state of Minnesota, this entails 2 registrations, because the state of Minnesota requires that the aircraft be registered just like boats do in most states. When I was flying out of Tennessee, there was no state registration. But 91.203 again, there must be an effective U.S. registration certified to its owner. The federal registration, that's the one that regulation talks about, must be done every 3 years. It was initially just like the airworthiness certificate, there was one registration and you only have to re-register the airplane when you sold it, or if the name on the registration was a human being and that person died, then you'd have to re-register the airplane. But after 9/11, well, that's my opinion, I'll skip that one. So the FAA said they were running out of tail numbers. And so about 10 years back, they said we need to have everybody re-register their airplanes and then to start over from almost from the beginning, and then register them every 3 years to make sure that the airplane is still in use. Am I? Got somebody there? In the state of Minnesota, there's the state regulation 360.59 for those of you who like numbers, that says that the aircraft registration is required for listing for taxation. Basically, the money that the state of Minnesota gleans from their registration goes to the Department of Aeronautics, which they use to help with the airports in the state and many aviation programs to help the pilots and promote aviation in the state of Minnesota itself. Sometimes the second R in AERO is dropped because this regulation used to be for everybody going and all aircraft flying in the United States. But back in the 90s, this requirement for having a radio station license in the airplane for flying inside the United States was dropped. And now if you go to fcc.gov, the Federal Communication Commission, it states in there that you only need a radio station license if you travel to a foreign destination. Of course, and now that's what their airplane needs, because basically the radio station license allows you to key the mic, turn the airplane into a radio station, and broadcast over the radio airwaves. But in order to be able to do that, talking on a VHF radio anyway, is the pilot will need a restricted radio telephone operator's permit. That's what I wrote down there at the bottom of this slide here. So if you're flying internationally, you not only need to have a radio station license for the airplane, but you need a restricted radio telephone operator's permit in your, along with all the other documents that you normally have to carry with you when you're a pilot. The reason I wrote in the word permit there and made sure I said that a couple of times is because if you go to the FCC site and look for a radio license, hoping to find this permit, you're never going to find it, because in the FCC world, everything that is a license, you got to take a test for. So if you're going to become a ham radio operator, you got to take a test and know Morse code. If you're flying for the airlines and you're flying across the ocean and you got to talk on an HF radio, you need to take an HF radio test to be able to talk on an HF radio. But if you're talking on a VHF radio, all you need is a restricted radio telephone operator's permit. You just fill in the application, send them about $70, and they'll get you that permit. And you only need that permit if you're flying internationally, talking on a VHF radio. The O, most people when they memorize Aero, think of the O as the operator's handbook, or the POH. But officially in 91.9, when you read that regulation, it's basically saying that, yes, you do need the POH in the airplane, but it also includes the manual, the markings, and the placards. So that includes all, so in most POHs, if you go to section 2, in the back of section 2, it lists all the placards that are required, what they need to say, where they need to be stuck on the airplane. And basically the way the thing reads is if those placards are unreadable or gone, the airplane's unairworthy, and you need to make sure that you replace that placard before you go fly the airplane. The limitation part is obviously all the limitations that are listed in the flight manual for the aircraft, but it also includes all the red, yellow, green, and white markings and all the gauges, so that you don't have to memorize every single number in section 2. When you start the airplane, when you start the engine, you look down at the oil pressure gauge. If the oil pressure is in the green, you know you're good to go. If it's in the yellow, you got to think about what's going on. If it's red, you're done. You shut the airplane down and try to figure out what's wrong with your airplane. So to me, the operations limitations are the POH, or the aircraft, the flight manual is required to be in the airplane, plus all the markings and placards, plus all the color coding on all the gauges. And finally, in the word Aero is the W for the weight and balance document. Now, most people say, is this thing required to be in the airplane? It's something that I don't think anywhere in the FAR is it specifically, or in the ones that we normally look at, does it specifically say we need the weight and balance document in the airplane. But when I read these two federal aviation regulations, Part 23 and Part 21, I get the impression that the weight and balance document is just like the placards and the color coding on the gauges, like in Part 91.9 that we just talked about. And it's an obviously important thing to have on the airplane, to know exactly what the basic empty weight of the airplane is, and what the moment is at that weight, or the center of gravity at that weight, so you know where to start doing the calculation for the weight and balance, which is something that we're going to talk about later, needs to be done for every flight. So this word Aero, So then with the airworthiness certificate not having an expiration date on it, we have to be able to know which, what maintenance must be done on the airplane throughout the, in order to be able to maintain the airworthiness of the airplane. So most people use the word AVIATE to remember all the various things that need to be done on the airplane. I do it slightly different than most people do. I start with the letter A being airworthiness directives, the V being the VOR, I is inspections. Most people do A as the annual and I as the Roman numeral 1 for 100 hours. But that way, if you do it this way, you don't forget that you need to look at the airworthiness directives too. Then the second A is altimeter, T for transponder, and E for ELT. So the A in airworthiness directives is from 39.7 in the Federal Aviation Regulations. Anyone who operates a product that does not meet the requirements of the applicable airworthiness directives is in violation of this section. So you have to make sure that all airworthiness directives have been complied with. You can go to the FAA.gov website and after doing a little bit of searching, come up with the airworthiness directives website where you can put in the type of airplane that you're flying, and it'll come up with all the airworthiness directives that are required for that airplane, all the one-time inspections that had to have been done on the airplane over the year that hopefully most of them already been taken care of, and all the recurring inspections that have to be done if there's something that they have to check periodically. In my flying life, I've noticed that, like in the Cessna world, you had to check the seat rails every 100 hours to make sure the little holes weren't getting too big. In the Pipers I'm flying now with Thunderbird, there's a stabilator cable that needs to be checked every 7 years or 2,000 hours, whichever happens first. So you have to, so if there's any recurring airworthiness directives, you have to make sure that you're complying with those. And for most of my students, I also teach that there's an emergency airworthiness directive that we all learned about when the 737 MAX had its problems with its flight control system, with the airplane doing things that the pilot was not asking it to do. So they immediately grounded all the airplanes to figure out what the problem was. So the letter A, the way I do AVIATE, the letter A is airworthiness directives. The letter V in AVIATE is for the VOR. It's in 91.171. And basically this one is talking about if you're flying IFR. If you're flying IFR, you got to check the VOR every 30 days to make sure that it is within limits. So if you're an IFR pilot, you've already learned this, that there's various checks that you can do, and the VOR check doesn't have to be done by a mechanic, doesn't have to be done by an avionics technician. It can be done by just about anybody, as long as you at the end of the check tell it what type of check it is, put down your name, the date that you did the check, and whatever the bearing error was for the type of check that you did. For those of you who haven't looked in the chart supplement book in a while, though, the types of checks are the VOT check, the ground VOR check at a designated ground point, an airborne checkpoint at a designated airborne checkpoint, an airborne checkpoint that you can make up on your own, or if you have two VORs in the airplane, you can check one against the other. The VOT check, the only two places in Minnesota that you can do that are the Minneapolis International Airport and the St. Paul Airport in downtown St. Paul. Both those have VOT signals that they send out from there. And you can check the VOT check. For that check, you need to have a tolerance of ±4 degrees. The ground checkpoint will be designated in the chart supplement book, what airport it is at, where on the airport it is. Usually there's a little circle there with an arrow on it pointing to where the VOR is. You just have to put your airplane inside the circle, look at a sign that's next to that point, and it'll tell you what the frequency is that you need to dial in and what radial you should be on if you're sitting in that circle. For that one, since it's a ground checkpoint, again, it's ±4 degrees. The designated airborne checkpoints seem to have disappeared from the chart supplement book. One of my Facebook forums that I'm working at is a CFI one, and so I put that in there saying, Does anybody else notice that the airborne checkpoints have disappeared? And does anybody know why? Nobody had a specific answer, but the best answer I found in the list of things that came back is it's probably a problem with the FAA being able to fly, especially since the pandemic, getting people out there to fly all the instrument approaches that they need to do, and also then fly to check all the VOR checkpoints that they need to. So I think the VOR checkpoints have kind of been put on the back burner for now, while they try to catch up with all the instrument approaches that they have to fly periodically to keep them up and running. Excuse me. So if you notice, if you go to the chart supplement book right now, most of the airborne all the checkpoints in the state of Minnesota anyway are gone, and everything in the north central aviation or the chart supplement book are gone. So if you want to do an airborne check, then you got to do what I call make your own. What the regulation says is you should be, not required, but you should be at least 20 nautical miles away from the VOR on a Victor airway over a prominent point on the ground, and when you fly over that point, check your VOR. It's got to be within plus or minus 6 of the radial designated on the Victor airway that you're flying. It has to be a Victor airway because, again, just like the instrument approaches, the FAA fly those things to make sure that the radial designated on the charts is the exact number that is supposed to be there. So you have to do it. So if you're flying IFR, you have to do a VOR check every 30 days. Then the next one is, since I'm using airworthiness directives as the first A, the I is inspections. For every airplane flying in the United States under US registry, you have to do an annual inspection. That's 91,409. Annual inspection is obviously you have 12 calendar months. You have the full month and the month it is due to get it done. An annual inspection has to be one that's done by an airframe and power plant mechanic with an inspection authorization. So so not any A&P can do an annual. It has to be an A&P with an inspection authorization. You can help that mechanic do that inspection if you want. If the mechanic agrees, you can do the non-inspection type of stuff to get the airplane ready to go. The mechanic will then come and look at the airplane, do the inspection, and then you can put all the stuff back once he's done. If the airplane is flying for hire, or if you're giving flight instruction in the airplane, then you must do a 100-hour inspection. I asked the mechanics that I know the only difference between the annual and the 100-hour inspection, the inspections are exactly the same. There's no difference in what they look at. The only difference here is the 100-hour can be done by any airframe and power plant mechanic. They do not need to have inspection authorization to be able to do the 100-hour inspection. You can you can't overfly the annual, but you can overfly the 100-hour by up to 10 hours if you have to take the airplane someplace to find the airframe and power plant mechanic with inspection authorization. But if it takes the full 10 hours to get there, the next 100 hours doing 90 hours, you don't gain any time by flying that. And if you're like Thunderbird Aviation, where we have our own mechanics on staff, we can't overfly the 100-hour because our mechanics are on staff, and so we don't have to fly the airplane anywhere to get there. So the A we use as the word altimeter, so it fits the word aviate, but basically it stands in for the static check. 91.411 tells you that if you're flying IFR, you need to have a static check within the preceding 24 calendar months. So they bring a box in and they hook the box up to the static port, and they check the altimeter at all the altitudes up to many thousands of feet above the altitude that the airplane can fly at, to make sure that at all altitudes that the airplane can fly, the altimeter is reading within 75 feet of the known elevation. The next one, the letter T, is the transponder. So any place a transponder is required, like within 30 nautical miles of a Class B airport, in and above Class C airspace and anywhere above 10,000 feet, a transponder is required you have to have a transponder with mode C. So but if it's a VFR only airplane, you don't have to check the mode C portion of the transponder. If the ATC doesn't like the number that they're seeing, they'll just tell you to stop altitude squawk. But if the airplane is flying IFR, thus you need the static check because you're flying IFR. In addition to the normal, does the transponder send out the right number in the 1200 part of it? Does it send out the right number there? Does it send it out the right signal strength? They will then also, while they're doing the static check, have a little receiver there to make sure that the transponder mode C portion of it is sending out the correct altitude. So that when you're actually flying IFR, they know that what they're reading on the scope is close enough to the altitude that you're actually flying. So they'll only check the mode C side if you ask the avionics technicians who are doing the static check to also are doing the transponder check to do the static check and the mode C portion of the transponder at the same time. But if it's an IFR only airplane and you're flying someplace where the mode C is required, you have to have your mode C on, but it does not have to have been checked. The only thing that needs to be checked every 24 calendar months is if a VFR only airplane is the mode A portion, basically the 4096 transponder portion. The reason it's called the 4096 transponder is because the highest number that you get in any transponder code is the number 7. So if it starts with 0 and goes to 7, there's 8 separate numbers that can go into each square. So if you multiply 8 times 8 times 8 times 8, you come up with 4096. Stand by. Oops. Bring people back in here, sorry. So that's the T in transponder. So then we go to, oops, a minute here. There it is, my little button back. The E in AVIATE for the required information for required maintenance that must be done on the airplane is the emergency locator transponder must be checked. This is 91207 letter D. The emergency locator transponder must be checked every 12 calendar months to make sure that it is operational and sending out a sufficient signal. If you're still like Thunderbird and you're flying around with an ELT that's on 121.5, they just tune the radio into 121.5, turn the ELT on, listen to a couple beeps and shut it off. And that must be done every 12 calendar months. In addition to that, in 91207 letter C, in the previous paragraph of that, the emergency locator transmitter battery has to be checked. Now there's two situations with the battery. If the ELT has been on more than 1 hour of cumulative use, so if you turn on the ELT on 5 minutes every day for 12 days, that's an hour of cumulative use. Or when 50% of the battery life is expired. Most of the time, when you buy a battery for an ELT, it's going to have the number of years or months that the battery is good for. You take that time, cut it in half, write that date down in your maintenance records for when the ELT is due. So if there's been more than 1 hour of cumulative use for the ELT, or the battery is past 50% of its life, then you must replace the battery if it's replaceable, or recharge it if it's a rechargeable battery. Most of the ones we fly at Thunderbird are all 121.5, and they're all replaceable batteries. So we just have to get a new ELT battery when 50% of the battery life comes up. So two separate things you got to worry about with ELT: make sure that every 12 months it's been checked for operation, and then keep a close eye on the battery. Now, most of the time with ELT, in my experience, the amount of time that they have to take when they do the check is so small that the 50% of the battery life is going to be up before they end up with an hour of cumulative use. What's most likely going to happen with that 1 hour rule is that you have a hard landing And by the time somebody figures out that it's your airplane that's transmitting on the ELT, that's your airplane's ELT that is transmitting, excuse me, then it's probably been 2 or 3 hours and you're going to have to replace the battery. You spent the money on the newer 406 megahertz ELTs, then you'll notice that you had to send in your name and address and phone numbers and all sorts of contact information when you registered that ELT, because if that one goes off, it sends out a digital signal that has a number on it. And when it's and that's the only one that the search and rescue satellites are listening to anymore. So with the search and rescue satellites, here's a 406 megahertz ELT, it sends that number to the search and rescue headquarters. And they look that number up in their database and they find your name and a phone number and they call the number. If you answer the phone, they'll say your ELT is going off, go over and shut it off. If you don't answer the phone, then they're going to start looking for it. So next we have 91103, the pre-flight actions that are required by this regulation. So most people use the acronym NW craft. So the first one is NOTAMs. Now, if you read 91103, and I usually have my instructors go through this, and because it's NW craft, and so I said, okay, show me in the reg where it says NOTAMs. Nowhere specifically in the regulations does say you have to check the NOTAMs, but the very, very first sentence in the regulation says the pilot must be familiar with all information required for that flight. So the the NOTAMs kind of fill into that all information situation. When I first started flying way back last century, there were NOTAM Ds and NOTAM Ls and FDC NOTAMs. Now there's, it just depends on which system you're looking at. There's all sorts of different types of NOTAMs, military NOTAMs and airspace NOTAMs, and but basically the designations, as far as I can tell, has been dropped down to NOTAM D, which is all NOTAMs that have to do with airports, and FDC NOTAMs, which have everything to do with instrument flying, changes to en route structures, changes to instrument approaches, and because they didn't have any place to put it way back last century, that's where all the TFRs went, because way back last century, TFRs were not that big a deal. So now the TFRs are listed on there's an FAA website specifically for TFRs that lists all the TFRs that are going on in the United States, both the ones that are really temporary and the ones that are more like permanent temporary flight restrictions, like the big one around Washington D.C. There's one around Disneyland and Disney World. There's one up in Grand Forks, North Dakota. That's always there because that's where they fly. Teach the pilots how to fly drones. There's the one that comes out periodically that you will find in the FDC NOTAMs that talks about it's up near Hibbing, near one of the open pit mines, and now that TFR will come into effect when they're about to blow another wall out in the mine, dig for more taconite. So but the only TFR NOTAM that is not listed anywhere in the FAA world, but is designated if you're a ForeFlight person, is designated in ForeFlight, is the TFR NOTAMs that have to do with the stadium. The FAA says, we told you what the rules are, Mr. Pilot, Mr. and Ms. Pilot. You got to have, if it seats more than 30,000 people, and there's a game going on there, the TFR exists for 3 miles around that stadium, up to 3,000 feet AGL. You need to stay out of that airspace. So it was up to us as pilots to figure out if something was going on at that space and stay out of there. So ForeFlight said, well, that, we can do better than that. I think what they've done is taken all the stadiums in the United States that have 30,000 seats, talked to the people who operate those stadiums, gotten all the sports information about when a game is going on at those places, and they'll put a circle around the stadium when there's a game going on. Now, I still got to take it with a grain of salt. It will be yellow on the day that the game's going to go on. An hour before the game starts, it'll turn red, but it also is supposed to exist an hour after the game ends. So I think ForeFlight is basically guessing when the game is going to end, so you just have to be careful, but it'll just turn back to yellow. So basically, there's a game going on at that stadium while you're flying that day, just stay away from it. It'd probably be better the way to say it, better, easiest way to do it. Sometimes if you're flying from a towered airport and there's a stadium TFR nearby, I know that in the Twin Cities area, they'll put it in the ATIS, letting you know that the stadium TFR is in effect around whatever stadium it happens to be at, whether it's the Twin Stadium, Gopher Stadium, or Viking Stadium. And it doesn't make any difference how good the team is or how many people are actually sitting in the seats. If it's a 30,000 seat stadium, then the TFR exists. When I was getting my master's at Middle Tennessee State University, the football team, or all the teams at Middle Tennessee State, are called the Blue Raiders. Back when I was going there, the Blue Raiders were like the world's worst football team, at least in that conference. And they had to switch over to playing their football games on Thursday, because Middle Tennessee State was one of those places where all the students would take their classes so that they'd have Friday through Sunday off. So all their classes would be done on Thursday. So they had to put the football game on Thursday so they could at least catch the students before they left campus. So they were lucky on a good day to get 3,000 people in the stadium. But because it held 30,000 seats, because it had 30,000 seats in it, the TFR existed around it. And just in the very outer edge of that 3 miles was the Murfreesboro Airport, where the aviation department for Middle Tennessee State did all their flight training. So we had to come up with some special agreements with the FAA and the local and the approach control at Nashville Airport to be able to fly in and out of the airport with when the TFR was in existence. So then the pre-flight actions in the NW craft order is not exactly in this order in the regulation. You have to check and make sure that you have weather, especially if you're flying IFR or not in the vicinity of the airport, although it behooves you to check the weather even if you're just going out to the practice area and back. But this weather that you're looking at, especially for an IFR flight or flying not in the vicinity of the airport, has to be an official weather briefing. So way back last century, that was getting on the phone, dialing 1-800 weather brief, or even before that, just looking it up in the chart, the airport flight directory, because that's what it's called back then, the AFD. Now it's a chart supplement book. Find the number to call your local flight service station to be able to get a weather briefing. Or like here in Minnesota, you could fly to the Princeton Airport, taxi over, park behind the little green building that was on one end of the runway there, and go into the building and get a personal face-to-face weather briefing. So then they got your name and your tail number and where you were going, and all that information was required in order for it to be official weather briefing. So if you're using ForeFlight and you're just tapping on the airports or looking at all the dots that appear on the screen there for the various color codings of the METAR reports, or if you're looking at all the weather information that is on there, it's a good way to do that. It's an excellent way to get an idea of what the weather is doing, but that is not an official weather briefing. If you go to the Aviation Weather Center online and look at all the same information, but it's not color coded like it is at ForeFlight, so you got to read it and make sure you know what all the abbreviations mean and everything. But again, because you're not giving your name or your tail number or where you're going, it's not an official weather briefing. It's good weather information. It's an excellent place to go and look at it, but it's not an official weather briefing. So in order to get an official weather briefing, if you're on ForeFlight, you have to put in a flight in the flight plan, even if it's just going in a local area, like from flying out of Crystal Airport, you go KMIC to KCFE and back, and then go to the section that gives you the flight section, And in that, click the briefing box, and it'll send the information out from your ForeFlight with your name, tail number, and where you're going, and get an official weather briefing. You don't even have to look at it, but that is giving you an official weather briefing. The phone number now, you don't even have to look it up anymore, is 1-800-WX-BRIEF. So that's the numbers you dial on the phone, but the company that now owns that, because the federal government has gotten out of the flight service station business, the company that now owns that has a website, 1-800-WXBrief.com. If you go on that website, put in your tail number, where you're going, and your name. You can even register on that website so that you don't even have to do that every time. You just sign in and then get a weather briefing for that route of flight that you're flying. Even if it's a local area brief, that's an official weather briefing. So you just have to be careful of, to make sure that this requirement, especially flying IFR or not in the vicinity of the airport, that you do get an official weather briefing before you, before you go flying. So the K in NW craft is known traffic delays. Most of the time, this is for IFR folks, but it's one of the things that's in the pre-flight actions. But if you're specifically flying IFR and going a fairly long distance, you want to make sure that you know if there's any traffic delays along your route of flight, to make sure that you're going to be able to complete the flight as you planned with the amount of fuel that you have on board. For any flight that you're flying, you want to make sure that you know what the runway lengths are. And in the regulation 91-103, it doesn't say alternates, it says alternatives. So this basically, using the word alternatives, works with any kind of flying that you're doing. If you're flying VFR, so you don't have to declare an alternate because you're not flying IFR, or if the weather's good enough and you're flying IFR, you don't need to declare an alternate. But what they're saying here in the pre-flight actions is take a look at your route, look at the weather, look for the known traffic delays, figure out the runway lengths, or the especially looking at the NOTAMs to see if there's anything that might be out of the ordinary for the flight that you're going to do, and be ready for those situations and have alternatives available to you so that you can have an idea of alternate things that you can do if things aren't going to go as planned. The F in NW craft is fuel requirements. If you're flying VFR, you need 30 minutes of the fuel to your destination plus 30 minutes. If you're flying VFR at night, you need fuel to your destination plus 45 minutes. If you're flying IFR day or night, you need fuel to your destination plus fuel to your alternate plus 45 minutes after that. All that fuel must be on the airplane before you leave your original airport. And if you belong to a club, or like Thunderbird Aviation has their own rule that says no matter when you're flying or what kind of flying you're doing, you need to have an hour of extra fuel in the airplane beyond the planned fuel for the VFR or IFR flight that you're doing. And so the other reason you need to know the runway lengths a little bit earlier is because for any flight, you need to know the takeoff and landing distance for your airplane. Going into the approved flight manual, the POH, going into section 5, looking in the takeoff section is usually fairly close to the front of section 5. The landing distance stuff is usually fairly close to the back. Again, the knowing that you need, so why do you need to do weight and balance? Because most of the takeoff distances in most planes that I've been flying have a way of being able to figure out what the length is going to be based on how much your airplane weighs. Sometimes, like in the Cessna world, the landing distance is just based on the maximum weight in the airplane. But like in the Piper world, just like the takeoff distances, the landing distances will be modified depending on how much your airplane weighs when at your destination. So in order to be able to do the takeoff and landing distance as accurately as you possibly want to, then doing weight and balance becomes something that you need to do. besides just have the weight and balance document in the airplane, like we talked about a little bit ago with the required documents. So 91-205 is the regulation that talks about all the required equipment for the various types of flying that you can do. So paragraph B talks about those things that are required for VFR day. Some people use variations on this theme. I was taught tomato flames when I first started. Then when they added a couple extra things like we're going to talk about here, then I switched to AF tomato flames. Those of you who went to Embry-Riddle Aeronautical University may have learned atom squared FLEAF, where it's 2 A's, 2 T's, 2 O's, 2 M's, and then the word FLEAF, F-L-E-A-F, in order to be able to get all these things in there. But AF tomato flames is more like real words, so sometimes it's a little bit easier to remember. So the letter A in AF tomato flames is anti-collision lights. Now, the anti-collision lights were not always a daytime requirement. They're only required in aircraft certificated after March 11th, 1996. The FAA is very good about stuff like this to make sure that we don't have to go all the way back to the Wright Flyer in the Smithsonian Museum and put anti-collision lights on it because they decided to add a rule in there. So they'll always call the grandfather all the old airplanes into what the old rules were and say from this date forward, you must have anti-collision lights on board your airplane. So that's why basically it became A tomato flames. But talking to my friends out at Embry-Riddle Aeronautical University, I've added the second F to my reminders, which is flotation devices. This is only if you're flying for hire and you're outside the gliding distance of the shore so, even if you're like 500 feet above Lake Mille Lacs, if you're flying over the middle of the lake and you're flying for hire and you're looking for fish or something, then you have to have flotation devices on board your airplane because you're not going to, if you're only 500 feet above the water, you're not going to be able to glide to the shore. Now, if you're not flying for hire, but you're flying over Lake Michigan, and then it's probably probably an excellent idea for you to bring flotation devices with you, but the FAA in their infinite wisdom has decided since people are paying you to do it, then you have to have it. If you're not, it's up to you. So now back to the tomato flames that most people have learned. The T is for the tachometer, one for each engine, and for the multi-engine folks out there, so you can tell how fast the engine's running. You need an oil pressure gauge because you make sure that the lubrication in the engine is working correctly. You want to make sure that you have an oil pressure gauge on board your airplane. Make sure that the pressure is good. And for most airplanes, if you start the engine, the oil pressure needs to be up and good within 30 seconds. And so in my mind, I keep the two pressure things next to each other. So the first M in tomato flames is a manifold pressure gauge. The one in the regulation here, 91-205, says you need this if it's an altitude engine. The way I read that is if your airplane has a turbocharger or a supercharger of some type, then you have to have a manifold pressure gauge to make sure that you're not over boosting the engine. Now, most people, the first time they see a manifold pressure gauge is when they fly an airplane with a controllable pitch propeller, when they start learning complex airplane type things for their commercial certificate, or because that's the type of airplane that they've decided to buy. But the reason that manifold pressure gauge is in the airplane is because whoever the engine manufacturer is, they said if you're going to put a controllable pitch propeller on my airplane, you need to put a manifold pressure gauge inside the cockpit to make sure that the pilot's not over boosting the engine by having the prop speed too low and the throttle too high. So then the A is an airspeed indicator. It doesn't have to be anything fancy, just tells you how fast the airplane is flying. So then the second T in tomato is a temperature gauge if you're flying in a liquid cooled engine. And then the O in tomato is an oil temperature gauge if you're flying in an air cooled engine. So most of us have never seen a temperature gauge in an airplane because all the airplanes that I've flown have all been air cooled. So the only gauge we have that tells how the engine temperature is doing is the oil temperature gauge. Then we start into the flames portion of the thing. You need to have fuel gauges, one per tank in the airplane. You need to have a landing gear position indicator if the airplane is has if the landing gear retracts. So you have to be able to tell whether the gear is up or down. So this is not going to be on all airplanes. You need an altimeter. Doesn't have to be fancy, although most of the time it's going to be a sensitive altimeter, which we're going to talk about a little bit later. But this type of altimeter is just going to be something that you set to 0 when you take off, so you know how high above the airport you are when you're flying around. For VFR, that doesn't have to be a fancy altimeter because you're supposed to be able to look out the window and see that there's a tower there or there's a hill up ahead, and then just climb to a higher altitude to avoid that. 91-205, you need a magnetic compass. The E is the ELT, which we already talked about the inspections and stuff for. And finally, the S is seat belts and shoulder harnesses. The safety belt must be worn by every occupant that's over 2 years old. And the reason I do seat belts and shoulder harnesses is because it wasn't until 1978 that the shoulder harness was required in the airplane. Until that point, all you had was a lap belt, a safety belt across, that just went across the seat, across your lap. The shoulder harnesses were required for front seats in 1978, and for small general aviation airplanes, it became required for all seats after 1986. So if an airplane that's certificated after the 12th of December 1986, then you'll have shoulder harnesses in all the seats in the airplane. So if you have passengers back there, you got to teach them how to put the shoulder harness on and take the shoulder harness off. So now we go to the paragraph C in 91-205. It talks about VFR night requirements. So you need all the stuff in paragraph B, AF tomato flames, plus most people use the word flaps to remember everything that they need to for nighttime. If you have fuses in the airplane that the pilot has access to, then you need to have 3 of each type or 1 full set to carry with you while you're flying. So those of you who remember what a fuse is, most of the time in most airplanes now, the fuses have been replaced by circuit breakers. They both do the same thing. They protect the airplane from an overamperage. And the fuse, it's a wire inside the fuse there that the electricity flows through. If too many amps flow through the wire, it heats up. Or as amps flow through the wire, it heats up. If the amps get too high, the wire inside the fuse gets too hot and it melts and breaks the circuit. So the only way to get the electricity flowing into that circuit again is take the old fuse out and put the new fuse in. That's why for night requirements, you have to carry fuses with you if you have fuses in the airplane. And the circuit breakers, it's the thing will pop, but most circuit breakers are doing the same thing. If there's too many amps flowing through the circuit gets too hot, the circuit breaker's spring inside will pop the button and open up the circuit. If you push it right back in, it's probably still too hot. The thing's going to pop right back out. And so most people teach only replace the fuse once, reset the circuit breaker once. So if a circuit breaker pops, you may want to do like what they used to tell us in the Air Force: wind the clock, settle down, look at the checklist, see if there's any checklist in there that tells you how to handle the situation for that circuit breaker that popped. Wait a little while, let the thing cool down, do what the checklist says if there is one, then reset the circuit breaker. Then if it pops out again, you know that there's really something wrong with that circuit. The landing light, only if you're flying for hire. Now, it's not very smart to go flying at night without a landing light. It's really, really difficult to see the runway sometimes, depending on what kind of runway you're landing at. But it's only required to be operational on your airplane if you're flying for hire. And so then if you own an airplane that was certificated before 1996, then you only need anti-collision lights if you're flying in the dark. The P is for position lights. I put the little picture down here in the corner that's been here the whole time. There are 3 colors of position lights. Position lights are the ones that are steady, and the collision lights are the ones that flash. Position lights are red and green on the wingtips and white pointing backwards. Sometimes it's on the tail, like in our little picture. Some of our Pipers, they're in a little attachment at in the front it's the red or the green light, in the middle is the anti-collision light, and in the back is the white light. So in some of our Piper Warriors, there's two white lights pointing backwards, both on each wingtip. Some of the Cessnas will have two white lights on the tail, and they're actually attached to the rudder. So as the rudder moves, the white light moves too. But the reason the lights are set in this situation is the reason they're called position lights, even though, which in all airplanes call them nav lights, is because when you're flying in the dark, you can look out of the colors of the lights in front of you to figure out what's going on. Because the red and the green lights are only visible from the front and from the side. If you see red and green, the airplane's coming straight at you. You don't have to worry about that the red's on the left or the right, or the green's on the left or the right. You don't have to worry about that, because if you see both colors, it's coming straight at you. If you only see red, then the airplane is going from, if you only see red, then the airplane is going from the right to the left. If you see green, it's going from the left to the right. If you only see the white steady lights, then the airplane is going straight away from you. So that's why they're called position lights. And the S is for a source of power. Doesn't have to be an alternator, doesn't have to be a generator, it can just be a battery. I went to the Albuquerque Balloon Fest many years ago. And I had to get up like at dark 30 in the morning for one of the shows that they did. When the blower, the flame that they create to create the hot air that makes the balloon rise, most of the time is tuned to the point where there's absolutely just the exact right amount of oxygen going in with the propane gas that they're pointing into that thing, so the thing burns blue. And even in the dark, you can barely see the blue light. But if you detune it a little bit, put in a little bit more oxygen, the flame turns yellow, and it'll light up the whole envelope of the balloon. And so at one point during the week, you get there really early in the morning, and the reason they do it in Albuquerque is because there's a wind situation that happens there up near the mountains, where up to about 200 feet in the air, the wind is blowing one direction. When you get above 200 feet, the wind blows the other direction. They call it the box. So if you get a balloon in that, you fly one way for a little while, then you add heat to the balloon, it rises up, catches the wind going the other direction, and so they can put bleachers out there, and you can watch these balloons just fly around in front of you. And so then they'll detune the thing, and they'll have music playing, and the different balloon envelopes are all going up. But because it's at night, they need to have position lights. So they have a battery inside the basket. And I didn't see any red or green lights, but I did see the white flashing light for the anti-collision light, and I saw the white light, steady light for the position light. They didn't go anywhere. They just stayed right there in front of the stands. But because they were flying at night, they had to have the anti-collision lights and the position lights, and their source of power was just a battery in the basket. So then, finally, in 91205, it talks about IFR. So you need all the stuff for VFR day, if you're flying IFR in the daytime, and if you're flying IFR at night, you need everything in paragraph C. So basically, if you're flying IFR at night, you need A, estimated flames and flaps, and the word I use is grab card. So the G in grab card is generator, or basically most of the airplanes we fly, it's an alternator, something that is creating electricity. So you can't fly IFR with just a battery. You got to be able to take off from the ground where something is generating electricity for your airplane. You need radios, both COM and NAV. So you need radios to be able to establish two-way radio communication to fly IFR, and you need navigation radios suitable for the route that you're flying. So if you're up in Alaska and you're flying NDB to NDB, then all you need in your airplane is an ADF. If you're flying someplace where all they have is VORs, then all you need is VOR. But if you're going to use both, then you got to have both. If you're going to have someplace where you're going to be flying an ILS approach, then you got to have a localizer with a glide slope antenna, be able to get that information into your airplane. And if you're flying GPS routes or going direct someplace, IFR, then you need a GPS on board. But it doesn't require you to have a specific type of navigation radio, just the navigation radio suitable for the route to be flown. So most people remember grab card and the first R is radios, but sometimes they forget that that's two different types of radios that are required by that portion of the regulation. Two-way radio communication and navigation radios. There's an altimeter again, just like it was in the AF-estimated flames, but now the altimeter must be sensitive. It has to have, you have to be able to set an altimeter setting in there in order to be able to get the exact, so that you know exactly what altitude you're flying within 75 feet. That's why the altimeter needs to be checked every 24 calendar months to make sure that the sensitivity of the altimeter is exactly where it needs to be. You need to have a ball. For grab card, we use the word ball, but basically that's the inclinometer, the little piece usually in the turn coordinator that tells you whether you're coordinated or not. The C in card is a clock. You have a clock that's installed that needs to be due hours, minutes, and seconds. It can either be, you know, an old analog with 3 hands on it. It can be digital. Doesn't make any difference, but it has to be installed and working before you leave the ground. Once the airplane leaves the ground, if it quits, then you can use your watch or any other type of clock that you have available to you to time things. But to fly IFR, you need a clock operational installed in the airplane before you leave the ground. Obviously, to be able to keep the rubber side down when you're flying in the clouds, you need an attitude indicator. And along with the inclinometer, the ball from the grab part, you need a rate of turn indicator, something that tells you whether you're flying a standard rate turn or not. Some of the new glass cockpits have some innovative ways of doing this, and they're almost too sensitive sometimes. But the ones that we're flying now in our Garmin 430s that we put in our airplanes that are connected to the Garmin G5 glass instruments that we have inside there, will take your airspeed and figure out what bank angle you need to do in order to be able to fly a standard rate turn, and put a little green triangle on the arc that is the bank angle indicator on the attitude indicator, so that you know exactly what to roll to do a standard rate turn. And so if you roll right to the green triangle, our electric gyro turn coordinator will be right pointing to the R or the L, depending on which way you're turning. And the turn coordinator on the gauge will be pointing, giving you the standard rate turn indication also. So the regulation says you need a directional gyro or equivalent. I added the or equivalent now because what we're flying inside our glass cockpit Archers, it's not really a full glass cockpit like a G1000. We have 2 G5s and a Garmin 430. But anyway, one of the G5s is an HSI, a heading horizontal situation indicator. So that's our equivalent directional gyro. It gets its magnetic direction information from a magnetometer that's out on the wingtip that goes through the ADARs, the air data and attitude heading and reference system, to then bring that information to the 2 glass instruments on our panel. And sometimes there's a second D, if depending on what kind of flying you're doing. If you're flying above 24,000 feet, then you need to have DME on board your airplane, or an equivalent to DME, like a GPS. So we'll get to questions here in a second. I will be getting the information about everybody who attended here in the everybody who attended, and I will go into the FASafety.gov site and give everybody credit probably within the next week. If you don't, just my emails on the emails in the request for this that you signed, where you went to the FASafety.gov to sign up for this. Just send me an email and I'll make sure that you get credit for this. Next month, on the 2nd Saturday of September, there'll be a maintenance seminar at 1 o'clock. Usually lasts about an hour. It's our director of maintenance, Paul Block, talks about various maintenance situations that pertain mostly to always to general aviation airplanes. It's probably getting to the time of year where I think this one will probably be a combination of some of the preventive maintenance that you can do as a pilot if you own or operate an airplane, and probably also the how to get your airplane weather ready for the winter weather that'll be coming up. Because by the next time you talk to you, it'll be December and the winter will probably be upon us. So let me stop sharing here. So, if there are any questions, you can unmute yourself and just ask the question.
Oh, it's Steve Suter. Can you hear me?
Yeah, just speak up a little bit more.
Hi.
Hang on a second, I had my headsets on a little bit earlier. Let me turn on my volume. There you go. Now I'm good.
Okay. I'm just curious, is the beacon that we turn on, is that a requirement or did I miss that under these regulations?
Before the engine starts?
Correct.
That's just, the beacon is one of the anti-collision lights that's required if you're flying at night. And the airplane was certificated after 1996. In some of the reading I've done, the beacon, turning a beacon on before you start the engine is just a way of warning people on the ramp that you're about to start the engine. In talking to some of the people who flew in World War II, they never turned their beacons on when they were going to start the engine because the prop was spinning. If the prop was spinning, they taught everybody, don't walk into the prop. But then jet engines happened. And with all the noise that was going on in the ramp, you couldn't tell whether the jet engine was actually on or not because of all the noise that was going on. And if you walk too close to an intake with a jet engine that was running, you could get sucked into the intake. So when they created jet engines, they decided to turn on the lights, start flashing lights on the airplane to warn everybody that A, we're about to start the engine, or that the engine is already running, stay away from the intakes. So I don't think it's any regulation or anything that requires us to turn the lights on before we start the engine. It's just a courtesy to the people walking around the ramp.
Great, thank you.
Any other questions? All right, well, thank you very much for coming then. Appreciate you participating in the safety seminar from Thunderbird Aviation and our local flight standards folks. And like I said, my director of maintenance will be with us next month, giving us a discussion on general aviation maintenance.